So you already learned how to solve a system of linear equations by graphing this first part, and now we're going to learn how to do it using the other two methods that you can. So the first one is the substitution method, and that's what we're going to do here. So to solve this set of linear equations using the substitution method, step 1 is you get one of the equations, you isolate a variable. So for example, in the second equation we're going to get the x alone because that looks easy. So step 1, isolate a variable in one equation. So that's the first step. And so we're going to use the second equation right here. X plus 3y is equal to 3. And so I'm going to move the 3y to the other side. So subtract 3y from one side. Subtract 3y. And now I get the equation x is equal to 3 minus 3y. And so what I did here is I got the x alone. I isolated the x in the second variable. And you can do this to any variable. You can isolate the y in the first variable, you can isolate the y in the second variable, the x in any of the equations, not variables. So all you need to do is you need to get one variable alone. We got the x alone in the second equation. So now that we have the x alone, we're going to plug that back into the first equation. So the first equation reads 2x plus 5y equals negative 5. So the second step is plug that variable into the other equation. So step 1 was isolate any variable in one equation. We isolated the x. Step 2 is plug that variable that you isolated into the other equation. So the other equation up here is 2x plus 4y, or 2x plus 5y equals negative 5. So you have 2x plus 5y is equal to negative 5. And we rearrange that second equation right here. X is equal to 3 minus 3y. So we did x is equal to 3 minus 3y. And so now we're going to plug in everything that's in this second equation. So the x equals 3 minus 3y. We're going to plug that into the x of the first equation. So how to do that? That's 2x, the x goes here, plus 5y is equal to negative 5. I just rewrote the first equation. Now I'm going to take this x that we isolated and put it into here. And so x equals 3 minus 3y. And so now you can see in the second equation what happened is it only has one variable. It used to have x and y. Now the second equation only has y's in it. And when you have one variable and some numbers, you can solve for that variable. So that's what we're going to do. So here, multiply out the 2. That's 6 minus 6y plus 5y is equal to negative 5. So let's combine the like terms. So the negative 6y and the positive 5y, that becomes 6 minus y, it's just negative 1y, is equal to negative 5. And now we want to get the y alone, so I'm going to subtract the 6 from this side, subtract the 6 from this side, and then I get negative y is equal to negative 11, because it's negative 5 minus 6. And then I'm just going to divide both sides by negative 1 to get rid of the negative here. And so the answer I get is y is equal to 11. So now that we know that y is equal to 11, the third and final step is actually to plug the variable you found back into any of the equations to get the x. So number 3, plug in the variable solution that you found into any equation. So in this scenario we found y equals 11. and I'm going to plug that into one of the two equations. I'll plug it into the second one. X plus 3y is equal to 3. So if you come down here and you do x plus 3y is equal to 3, where y is equal to 11, I'm going to plug that in. That's x plus 3 times 11 is equal to 3. That's x plus 33 is equal to 3. And then you just subtract 33 from both sides to get rid of it. And then I get x is equal to negative 30. And so there you have it. I found y is equal to 11, x is equal to negative 30. And if you want to write that as an ordered pair for the solution, it looks like negative 30, comma 11. And that's the solution. You can double check by plugging it back in, but that's the solution of the two equations using the substitution method. This last method of solving linear equations is called the elimination method. And in the elimination method, you basically add the two equations you have together and try to get rid of one of the variables so that you can solve for the other variable. So for example, in this example we have 3x minus 7y is equal to 10, and the second equation is 6x minus 8y is equal to 8. And so here you can do anything you want to one side of an equation as long as you do the same thing to the other side of the equation, and you'll get an equivalent equation. So for example, if I multiply this top equation by negative 2 and I multiply the right side by negative 2 as well, then the answer that I get is going to be the exact same equation. So for example, let's just do this. So if I get negative 6x plus 14y is equal to negative 20, this new equation, which is the same as the equation at the top multiplied by negative 2, is actually still the same exact equation. I just multiplied both sides by the same number. And so why did I do that? Why did I just multiply both sides by negative 2? Well, if you look at the second equation in this set of equations, the second equation is actually 6x minus 8y is equal to 8. The second equation has a 6x in it. It has a positive 6x. And so in the elimination method, you want to multiply one of the equations by a number so that you get the same exact coefficient in front of one of the variables. So this variable here is x, and I wanted to get a negative 6 on the first one because this bottom had a positive 6. And why? Because you can actually just add these together. You can add these two equations together to get a new equation. And when I add these equations together, the 6x disappears. It goes away because what's negative 6x plus 6x? It's 0. So the x's go away. And then if I add the y's, 14 minus 8, 6y is equal to negative 12. And then now I see that after I added those equations together, I only have an equation left with a y in it. So it no longer has an x and a y. I've eliminated the x's. I can just solve for y. So to solve for this y, divide by 6 here, and I get y is equal to negative 2. So basically, earlier in the substitution method, you were trying to solve for one of the variables the same way. But in this method, what you do is you add the two equations together. But before you add them together, you have to multiply one of the equations by a number so that one of the coefficients here, like here it's the 6, is the same, so that when you add them together it gets canceled. So here I made sure that this top x has a negative 6 in front of it because I knew the bottom x has a 6. And so you have to look at the equations and find what you can multiply by it to get something that will be easy to add. And so now that I know y equals negative 2, I can just plug it into one of the other equations. So let's pick the first equation. 3x minus 7y equals 10. So if we come down here, 3x. So let's rewrite this. So 3x minus 7y is equal to 10. Double check that that's right. 3x minus 7y is equal to 10, yep. And now we know that y is equal to negative 2, so I'm going to plug in the negative 2. And then I get 3x minus, plus 14 is equal to 10. And then you subtract the 14 from both sides. And then I get 3x is equal to negative 4. And then divide by 3. Divide by 3. And then I get the answer, x is equal to negative 4/3. So that means the solution to this is, written as an ordered pair, is negative 4/3, negative 2. Because we found that y equals negative 2, and we found that x equals negative 4/3.